He's Rob Winch, and I'm Josh Long. It's really good to meet you all here. The source code slides?
Yeah, source code slides. So if you want the slides or the source code, go ahead and use the bit.ly or the 3D barcode. My name is Rob Winch. I'm the project lead for Spring Security, and my good friend, Josh.
No, but how do I know that it's you?
How do you know?
How do they know that it's you? I authenticated you.
You authenticated.
Because I
You are a reliable source.
Right, I'm a certificate authority.
You're a Rob Winch authority.
Yeah, exactly. There you go.
Yeah.
And vice versa. So I think that's kind of cool. We did some security. We can go now. We're done. Look, the code is here. You're going to need it. Don't do it now. Just get the code later. There's a lot here. We're going to go through a lot. Not everything in security, but authentication. Is that about right?
Yeah. So if you were at our talk yesterday, we focused on some of the new features in Spring Security that focused around authorization. But today we're going to do some of the authentication bits. And if you're not familiar with it, authentication is the who. Who's trying to access a particular resource? And a lot of times we do that using a username password. But today we're going to discover some other ways that we can identify who is accessing a particular resource. And then there's authorization. Authorization is, given I know who's accessing that resource, are they allowed to access it? All right? So again, we're focused mostly on authentication today. Without further ado, we're going to do some coding.
Yeah, okay. Let's dive right into it. Look, we've got to do a lot of code here again, so keep that QR code handy for later. The usual applies, right? Start.spring.io. Where do I get the latest bits of Spring Security? Do I download it from an FTP somewhere?
I think someone puts it in a wheelbarrow and delivers it to your door.
Exactly. Security delivered hot and fresh every day. So we're going to go here, start.spring.io. A few decisions to make. What do I want to name it? Always, again, I'm great with names. I get that from my dad. He, too, was great with names. As I've said before, when I was a small child, we had a small white dog, and my father named him White Dog. So again, great with names. That's why I'm going to name my project having to do with authorization and authentication Auth, because I'm great with names. Java 21. GraalVM, sure. Web support, sure. Security, that feels mildly important.
Yeah, that should be.
Yeah, okay. Key.
Be on there.
Data, we want JDBC, surely. We're going to use a database. I'll use Postgres. Anything is fine except just, use Postgres. It's great. Actually, questions. Who's using Spring Security and Spring Boot 3.x? Okay. Who's using Spring Security and Spring Boot 2.x? No judging.
Some shy hands here.
We all did it once in
Don't
college.
worry, you're off camera.
There's no shame. I mean, there's only 3 or 4 cameras and a lot of people watching, but there's no judgment here. It's fine. What else? Yeah, okay. Java 17 or later. It's Java 21. Oh, okay.
So I like to see the old school. Who here has used Spring Framework with XML? Anyone? Okay. XML before namespace?
Oh.
Okay. This will really show your seniority here. Who's used a CG security before it was Spring Security? Yeah, there we go. All right.
We're going to do in one line of code what took 30 or 40 stanzas of XML 20 years ago to do with a CG.
Yeah.
And that'll be just one out of a million demos today. Okay. So GraalVM, Web, Security, JDBC, Postgres, hit generate. Gonna open this up in ye old IDE. Alrighty. I might have to re-import this. It's been a little fidgety. Let's do that right here. Maven, reload project. Okay, here we go. First things first, I've got a SQL database that contains information that we're gonna need. So what?
YAML.
Yeah, I'm gonna convert this to YAML first. Who's using YAML? Do you like it? Yeah, I mean, do you feel better about it? Because I don't. I go home sad every time I do that. But such as it is. Okay, so application.yaml auth Spring data source. Hiyo data source URL JDBC : This is not secure practice. Do not put your credentials in a YAML file. I feel like we're starting.
Do as he says, not as he does.
Yeah, exactly. We're starting on the worst foot possible. Password is secret. Okay, so that'll give us a connection. Let's just test it as such. Hit apply, hit OK, go, refresh. Okay. Neat. All right, we'll come back to that. Good. So let's build a simple application that does very simple authentication. I'll go back to the application here, auth application. And can you all see the font over there? Is Rob standing in the way? Okay. We're going to build a simple controller, class secured controller, and get mapping / map string hello, right? Hello. And return map.of message. Okay, and then hello user principal dot get name. Good. So there's a very simple map. Return that. Let's just start it up. And notice that I've done nothing else here, okay? I've already got a username and password, though, because Spring Security pre-configures one. If I go to the console there, localhost / login, user is the username, and then the password is what was printed on the console there. Okay, so it's worked, right? I've got a simple endpoint. It clearly knows who I am, although, I mean, it's just a default user. And the password changes every time, by the way, so, you know, the question then is, how do I get, like, real users in the system, not the default?
Yeah. How's this working? Is there an API that I should be aware of?
Exactly, right? They're behind the scenes, I guess there's this authentication manager, right? Is that the whole thing?
Yeah.
There's this hierarchy. How many of you have ever dealt with... Got it, okay. All right, nice. There's this hierarchy rooted in authentication manager that deals with authentication. And authentication is basically given a challenge, confirm that this person is who they say they are, or this client or whatever is who they say they are. And you do that by proving that they have something that only they could have. Is that the idea?
Yeah.
And so, broadly, this deals with that scheme. You send in an authentication, and if it's true, if it's valid, then you send back an authentication with the Boolean authenticated equals true. Now, most people are dealing with passwords. A lot of people are dealing with passwords.
Yeah.
So there's a whole sub-hierarchy underneath this stuff, rooted in, I think, user detail service. Is that about right?
Yes, sir.
Okay, and then, so this is another scheme, and you'll see this a lot. Basically, somebody presents a username, and we load a user details from sort of some sort of back-end system, be it LDAP,
Yeah.
a SQL database, whatever, right? Where else could you load it from?
Any data store. The thing that's pretty nice, though, is what a lot of people don't realize is Spring Security is doing things for you that you might forget. So when you load that user, you might think, oh, well, at this point, I just have to compare the password to the other password. But what about how you store your password? What about making sure that someone can't discover your user using certain types of attacks? Another one that typically will happen is you might forget to clear out your session and reset it after you've authenticated for session fixation. So even though you're only doing this and you're like, oh, I'm pretty much done, remember Spring Security is there taking care of things behind the scenes for you that you might not even think about.
Right. So this is a user detail service. We need an implementation of that. I think the easiest one we can use for tests is this one, right? It's an in-memory user details manager, like this, and I'm going to return a collection of users. So with username Rob.
With password encoder.
With default password encoder. Yeah, thank you. And that's deprecated. It's not for anything besides demo use. Okay, and we'll say dot roles is admin and user. Username is Rob. Password Shirley is PW. Don't ever do this. Ever in production. Okay, and here's me. And there we go. 2 users, Josh, PW. All look okay, and then return that. So I'm going to just provide this one bean. Ultimately, this is a user details service, right? That's the implementation type. So I'm going to plug that into the context, do nothing else, Rob, PW, I'm in, right? And I've got 2 users now. So if I go over here, log out, I can log out again, go to Josh, PW, that works fine. What does that buy me though, right? The reason that's useful is, of course, they have different rules. What that buys me is I have the ability to distinguish users with authorization, right? So authorization, and the easiest way to set that up is to sort of create this security filter chain. Return http.build authorization requests are any request authenticated, but then go back over here, and then I want to say request matchers /admin has to have a certain role, right? So I can say admin, for example. Okay, so that's the very, very simple form login. Yep, customizer with the defaults. So now I've got very simple login. I need to have a simple endpoint. Let's go ahead and copy and paste this. Okay, and we'll say admin, hello admin, and admin. Okay, so let me restart this application. restart, and now I will log in as me. Go to /, that works fine, but if I go to admin, 403, log out, right? Rob, he's got admin's role, so I can now go here. Okay, so now he is able to access both endpoints, but only the one. So this is a basic authentication and authorization. I'm storing everything in a in-memory database, and I've got the passwords encoded in my Java source code. That's not great.
Yeah, but you know what's interesting is we kind of glossed over this with default password encoder business. What if we logged out or printed out that password? What do you think, Josh? Maybe we could show them something that's happening behind the scenes here.
Okay, let's do it. So we get this thing right here. So this will be Rob, surely. Okay. System out rob.getPassword. Restart.
So you'll notice the password's going in as PW, and we're going to print out the password. So is it going to be PW or is it going to be something else?
Yep, here we go.
Right there, bcrypt. That's kind of interesting.
Yeah, so it's being encoded, right? That's a password encoder strategy behind the scenes. All right, so we got a password.
And I think we might have some slides to talk about that.
Yeah, go for it. Oh, yeah, I forgot about that. Woo! All right.
There we go. Let's see. All right. So the thing is we're talking about passwordless here in this talk. But in order to figure out why we want to go passwordless, we almost have to talk about the elephant in the room, passwords, okay? And to know about that, we need to talk about the history of passwords. So back in the day, people would store passwords in a database, and they would just store it in plain text. And they'd say, it's fine. It's fine because that database is protected by a password. And then we realized this is not such a great idea. And can anyone tell me why? There's tons of reasons why. I'll spare you the details, but a couple of them are SQL injection attack. SQL injection attack, don't need the password, dump the database, have access to all the passwords. Guess what else we realized after a bit of time? Everyone uses new passwords for every website, and they're unique and secure, random generated. Oh, no. They use password 1 for every website. They reuse their passwords everywhere, right? So one site that gets compromised compromises that user for every website, right? And so we realized that storing passwords in plain text was a bad idea. So we said, okay, well, what can we do? We could run it through a one-way hash function. We take the password, run it through the hash function, and then we store that. And then when we need to see if the user logs in, we say, okay, whatever they typed in, we run it through the same hash function, and then we compare the two hashes. If they're equal, then the user is who they said they were. Now, the thing that I want to point out is the function is one way. You send it through the function, and it hashes. You can't undo it. So it's not encryption, decryption. This is hashing, right? And we said, okay, well, this is great. This is working. It was too much back then for people to hack individual users. But what they realized is they don't need to hack individual users. They actually created these lookup tables called rainbow tables of all the passwords. They just, all the time, were computing password hashes, and they'd have the hash and then the original password. And if they saw the hash in a database dump, they'd know what the password was instantly. So instead of having to attack a single user, they attacked all the passwords at once. So we had to evolve again. And what we did then was we said, okay, instead of sending just the password through the hash, what if we added something called salt? Salt is just a random set of bytes that gets combined with the password, and they both get sent through the hash. And then the salt sits in plain text next to the password. And then when you need to authenticate the user, they take the salt plus whatever the user typed, sends it through the hash function, and sees if it's the same. And what does that do? Well, now the attacker can't just attack the password space. It has to do the secure random bytes, which is long, plus every password combination possible. And it became impractical for them to do these lookup tables. Welcome to the modern era. GPUs. Anyone heard of those? I hear they're a thing. Yeah?
Yeah.
Well, we can do billions of hashes a second now. Billions. And so that means now we can just crack the password. It's not really that big of a deal. We have cloud computing too, right? So storing a password has become much more complicated. So in the modern day and age, we have to do what's called one-way adaptive functions. And a one-way adaptive function is just that, it's adaptive. So you can add a workload so it can be improved security as the hardware gets better, but it's also intentionally resource intensive. What do I mean by resource intensive? Well, one resource is CPU, right? Another resource is memory. So it's intentionally resource intensive, which means that it's going to take a while. And in fact, you're encouraged to tune your password validation to take around 1 second. 1 second. So let's say we're validating a password on every request because we're using HTTP basic. How fast can your request be? At most 1 second, but there's still the stuff that you actually have to do. That's not ideal, is it? Big problem with passwords, right? We solved one problem and we created another. So what do? Well, we can't use the password long-term. We need to exchange it for a short-term credential, a long-term credential that needs stored very securely for a short-term credential that has less importance because it's probably not reused and it has a shorter lifespan. So you might exchange it for like a session identifier or in yes?
Token.
Yes,
but also
token.
you can't use it to revoke the original password.
Yes, you can't use it to revoke the original password. Very good. And so we just talked about some of the trade-offs. So the other thing that we realized, though, is when we're running it through these hashes, I said it was one way, right? So let's say we created a password in the day of plain text being fine. Super easy to migrate, right? But what happens if when you created the app, it was important to run it through just SHA-256 with maybe salt? Okay, that's great, but now you have the same set of users and you need to migrate those passwords to something more secure like bcrypt. How can you do that? You don't know what the original password is. By definition, it's one way. You could run it through a GPO and try to crack all their passwords, but I mean, probably don't want to be doing that, right? So how do you actually do this? Well, Spring Security's actually added some cool features. If you look at the first line there, it's just EDB. That's what your SHA-256 hash might look like. The next one is very typical bcrypt. It always has kind of like the version in front. That's what the 2A is. So that's very bcrypt. But how can they coexist in the database? And how can we migrate them? Well, Spring Security has a default password encoder now, and that password encoder can encode in one and read in many, or validate in many. So that's what the SHA-256 is. It says, okay, when you validate this password, you need to validate it using SHA-256. The next one, you need to validate using bcrypt, okay? And what we're gonna see is that Spring Security actually even has a strategy to automatically upgrade your passwords encoding as you go through this.
Okay, and we got 25 minutes. Let's dive right into this. So, I'm using in-memory right now. Everything is using the latest and greatest bcrypt. I want to use something that's more representative of an old system. So let's instead point it to a database that is, that contains my users' passwords as SHA-256, right? So I'll point it to that. This is going to use this SQL table that we have over here called users. And you can see that the old passwords, there's two of us, Josh and Rob, the old passwords here are in SHA-256, but how is Spring Security to know that? There's no precursor, there's no token in there that it can use to sort of pick that up. So I'm gonna run a little migration manually here. I'll say update users, set password equals SHA-256 password, okay? There we go. Okay, yeah. So now I'll go back to my table, select all from users. We got nothing. What happened? Update users. Oh, execute and suppress. Yes, please. And then select all from users. IntelliJ stopped me from doing something terrible there. Okay, so now it's updated. I've got the SHA-256. Let's rerun the application, having done nothing else yet to migrate. All right. And go back to the application. Admin Rob PW. There we go. Hello, admin Rob. Go back to our table. It doesn't reflect that it's upgraded. We need to give Spring Security some way to write back the change, and the way we can do that is by registering a user details password service, right? User password service, user details manager. Okay, return this, and hide that. Okay, here we go. var updated equals user.with user details user.new password, and then build, right? So I'm copying the old one, I'm going to use the UDM to update the data in the database there, and I'll return that updated one there. So I'm delegating to the user details manager, but I'm doing the update here with an implementation of user password service, user details password service. Log in again, refresh. That one felt like it took a little longer, and then sure enough, it did. It actually upgraded. That's the only time when we have the actual password is when you're logging in, right? We know what it is because you typed it in the challenge. So we were able to then migrate it to bcrypt behind the scenes seamlessly. So as users log in, they get upgraded to the new stuff securely. So this is great, but it's still passwords.
Yeah, there's still problems with the passwords. Remember, we talked about people reusing passwords. We talked about insecure passwords, sticky notes, etc.
Yeah. So I think we should get on with the having passwords. All right. So what's next?
So now I think it would be really interesting is if we added passkeys. What do you think?
Yeah, let's do that one. So I'm going to go to my build here and I'm going to update it. We've got a few things that are not yet GA, but they're you can try them out. We want you to try them out. Spring Security .version, and there's notes in the slides on how to get this code. Okay, so this is all sort of out there at the moment. Snapshot, and I'm going to bring in Rob's starter here.
We're doing a snapshot? What could go wrong with that?
Nothing. Fine.
Nothing. It'll be fine.
So this is a separate project on which Rob is working. This will get, I guess, will this be in main branch eventually?
Yes, eventually.
That's the goal?
Yep.
We would love your feedback, friends. And of course, the DSL. Right now, we're using the generic Spring Security infrastructure here to use a configurer, a third-party configure with. But eventually, of course, this will just get merged in, right? So static import c.rp name. This is arbitrary. It's just a name of a thing. Do you want to talk about passkeys while I'm doing this?
Well,
or do you want to see the slides?
The slides would probably be helpful for
localhost.
We can do this first, and then we'll do the slides.
Okay, I like that idea.
Yeah, there's some diagrams that I don't draw very well in the air, so.
Okay, so that was all I had to do to make it work. But what am I making work? Let's go talk about that quickly. With 21 minutes to go on the clock. Oh God.
All right. So I think the best way to talk about what passkeys are is very quick and simple. You can authenticate without a password. All right, but what does that look like? Anyone here using passkeys, by the way? Okay. All right, so first you need to register the passkey. And the way that you can do that is either at the time of creating the user account or after the user's logged in with a different way of authenticating, like using a username password. Once you've done that, then you can click like a register button, execute some JavaScript. The browser then can prompt you to create a passkey. And it can let you select one that's existing, or you can scan a 3D barcode with your phone and associate your phone to that browser. Once that happens, it'll say, please create a passkey for this host, and it will allow you to say yes, and then it does some sort of biometric confirmation, or maybe if your phone is using a PIN, you use that. Once that is done, you've registered the passkey with your account. At that point, you can sign in. So it says, okay, do you want to use a saved passkey? Yes, select the device, check your device, it sends a notification. Your phone now enters this prompt, and you can say continue, unlock it, just like we did before. And now we are logged in on the phone? No, on the desktop. Interesting. I even entered my credentials on a different device. But you can also provide the passkey from your actual device. You don't have to do it from a phone. So this is really nice because if I have a passkey registered and Josh wants me to log into his laptop because he's trying to steal my password, because he likes to do jokes like that, I can actually scan the 3D barcode with my phone, log in with my phone, never even entering a password,
right,
and it'll authenticate on his laptop or a library or, like a shared computer or whatever. And so how do passkeys work at a glance? We'll go over this very quickly because it's not super exciting, and Spring Security will take care of this for you. But when you register, you have to get some options from the server. You take those options, pass it into a JavaScript function, and then you have to validate and save those options. Once you're trying to authenticate, you get some options, send it into a different JavaScript function, and then you validate the credential on the server side. So how do we validate those credentials? And in order to do that, it's valuable to talk about how we validate things in real life. If Josh and I agree to this contract, we might sign the contract. How do we know if that contract, like my signature, is valid? Well, you might have to compare it against like an identification by a known trusted authority like the government. and then you can compare those. But the problem is once I've verified that signature, is I can actually produce the signature. Verification means I can produce it. So the same thing I use to verify also produces it. So now Josh is like, hey, I'll create my own contract and forge Rob Winch's signature, and now I owe Josh $2 million. No one can prove otherwise.
Yep.
So then I could also forge or add something to the original document, right? So he actually signed this document. I could actually amend it. The nice thing is asymmetric cryptography prevents this from happening. It has a way to prevent this. And the reason is the private key stays private. Public key can be shared. Private key can produce signatures, and the public key can validate signatures, but it cannot produce the signature. So what I'm using to validate is different than what I use to produce. Taking a look at that, if I take the private key and run the text through the function, it comes out as a unique signature. That signature is unique for that private key and that text combination. No one else can produce that signature for that combination. On the public side, you take that public key and the text and the unique signature, it will say yes or no. Was it produced by the person that had that private key? And taking that one step further with passkeys, how do passkeys work? Well, the options that are sent from the server include a user ID and a challenge when you're registering. And those are sent through the JavaScript function to the authenticator, and the authenticator prompts the user. You click the use the biometrics or a PIN or whatever to confirm that you want to do it, and then it asks to generate the key pair, public and private key. The private key stays in the authenticator, mobile device or a TPM or whatever, and it sends the public key and the signature over to the server. The server then verifies the signature and the public key, and now we're able to authenticate. So it's pretty much the same thing. Challenge to a new JavaScript function, prompts for verification, biometrics, signs the challenge, and remember the private key stays on the authenticator. So the user says, please sign that challenge. It sends the user ID and the signature over to the server. The server uses the user ID to look up the public key that was stored previously and make sure that the signature is verified. But the server never has the private key, so it can't leak the credential that can produce the authenticated user.
Yep. Okay.
Well, I know Josh is very eager to code.
16 minutes.
16 minutes. How do passkeys protect against phishing? One of the things that sends across the wire is the browser's domain, and the browser is providing that. So if someone's trying to phish, it cannot do that. Also, the credentials are unique per domain. How do they improve credential storage? We talked about that. It's storing something that's public anyway, so if it leaks, it doesn't matter.
Okay. Oh my goodness. Okay, so the good news is that demo's already done, right? I wrote those 5 lines of code, and we got web authent or passkeys. Gonna go ahead and restart this. Here we go. Log in again, but this time, notice that we've got this snazzy little button down here. I can't log in just yet because I haven't registered one. I'll go to the login with the username and password one time. Spring Security sets up a special endpoint here, web authent register. I'm gonna say beautiful passkeys register. It's gonna prompt me. This is an Apple Macintosh MacBook Pro. I'm gonna use my Touch ID to authenticate. It'll register that. Now I go to log out. Log out, here we go. And now, this time, I can just do this, right? Click on that. I'm using my finger rather. And now I'm authenticated. It's tied, I'm not Rob in this case, but you get the idea. So that means that if I have that same fingerprint on some other device, would that work?
It's not the fingerprint, it's the
identity.
It's the private key that's associated with it.
So,
and that's interesting because a lot of a lot of these providers of passkeys will sync it across the wire. So the private key might be synced using Keychain, for example.
Apple iCloud,
iCloud,
and Google, I'm sure, and
yep.
LastPass, OnePass, they all probably have something like that.
Yeah.
So if you get it right once, you're now authenticated across all the places that know about this passkey, but they're not getting anything they're not getting anything besides the public key.
Yep.
Which is great. Okay, so that was easy. That was too easy. It's literally just these lines.
It took
of code.
longer to explain it than it did to code it, right?
and the result is really, really easy login with no pain at all. What's another way that's very common to log in?
It would be really cool if we could do like a magic link.
Aha. So you want to do the demo first?
Let's do the demo.
Talk about it?
Are we short on time? I can explain while we're talking. Yeah, we're short on time. I'll talk while he's doing it. So magic keys aren't, magic links aren't too hard to explain. You type in your username or an email address, and then it sends you a notification via a pre-registered, pre-confirmed means of communication, like a SMS or an email. And then once it does that, that notification has a token in it, and possibly a link that provides the token for you. And since it's doing that, it's proving that you have access to that communication device and allows you to log in. And so Josh right now is setting up the ability to do that in our application.
Media type, text HTML. Okay, that look okay to you? So all I've done is I've used this one-time login support here, generating a handler. I'm going to print out, normally you'd send an email or send an SMS, but you know,
Console mail works too, right?
Yeah, console mail works, surely. Let's just go ahead and restart that. Revisit, okay. Now I've got yet another snazzy thing here. Request a one-time password. I'm going to log in as Josh this time. Nope, no, Josh. Send token. You've got console mail, thank you. Click on the link, copy the URL, paste. There you go, hello Josh, right? So I was able to do, again, imagine that in an email or something.
What happens if you use that again?
Oh, yeah, good idea. Well, okay, I can just paste the link again. Now it's an invalid token, it won't let me do it again.
Yeah, so it's one-time use.
Right.
That's pretty secure.
Is that why it's called one-time token?
Yeah, that's a good point. I hadn't thought of that.
Okay, great.
Yeah.
So now we have we have secure passwords, but also we've moved on beyond passwords. We have one-time tokens. We have passkeys. This is all very well and good. I get what's happening here in this one application, but my systems contain multitudes, right? I have lots of services, lots of applications. Couldn't I use? What if I centralize this identity management in one place and then wanted to reuse that definition elsewhere in the system? Is there something we could use to do that?
Maybe
sort of server?
Maybe an authorization server?
Yes.
Do we have one of those?
It should be called the authentication authorization server.
It could be.
It could be called the authn server, whatever. Okay, anyway, yes. So let's do that. Let's go back to our build. And
so does this mean we could go passwordless from user all the way to the service?
Heck yeah.
That's awesome.
Authorization server, hit OK, hit apply. Okay, very good. So all I've done is I've added the Spring authorization server starter. This is part of Spring Boot for the last two releases at least.
Yeah.
And I need to configure now an OAuth client. Do you want to talk about OAuth briefly while I set this up?
OAuth is a way of authorizing a user without necessarily needing to authenticate. Typically, you will have to authenticate them to confirm that they want to grant access, but OAuth is really about authorization. I have a token, a bearer token, I present it, and then the resource that is receiving it decides, are you allowed to access it? There's also a protocol built on top of OAuth called OIDC or OpenID Connect, which allows you to authenticate using the OAuth protocol. And the way that works is you get an access token, and then you use that access token to try to access a resource that provides the user information. And then that user information gets translated into the identity of the user.
Okay. And we want to do the match.
Media.
Media, thank you. Up. And we want media type HTML. Okay, that looks okay. What's wrong with it?
Semicolon, maybe?
Well, wait, no. Is it the authentication entry point?
Oh, default.
There you go. Yeah, there we go. Okay, so there's that, and we also need to specify the resource server stuff. Not here, right? Yeah, here.
Yeah. Oh, it's not in the exception handling. It's above exception handling. Can you make that lambdas? It'll be easier to read.
Yes. Place with lambda.
There you go. Now above exception handling, do the resource. There you go.
Server. www.jwt customizer with defaults. Okay. So now what I'm doing is I'm specifying some of the basic stuff you need for the authorization server to do its magic. Do I need anything else? Yeah.
Order.
Yeah. Order. One. Okay. And I've specified a client here.
We also need the.
Apply default security. Passing in HTTP. Let's go. Well. Thank you. And then we need http.getConfigurer OAuth2 configurer. No, authorization. Okay. .oidc customizer .with defaults. Okay.
Sure.
There we go. So I'm just applying some default security here. I'm setting up a second filter chain for my authorization server. And most importantly, I'm registering a client so that other devices can connect to this authorization server and say, hey, I am an iPhone, I am an Android device, I'm this website, I'm that website, and I'm asking on behalf of Rob or on behalf of Josh to act in their stead and use APIs that you have in their name, right? And I'm going to be bearing a token that proves that I am working on their behalf. So it's a client. That's what we're defining. The user, we've already looked at how the user comes into play. Let's start this thing up. We got a client named Spring and a client secret called Spring. And we're asking for certain flows to be supported. And once everything goes well, we're going to redirect back to the actual website. So we're going to go to the auth server, do the authentication and authorization, and then get redirected back to the app, which will have the token and can act on our behalf. Let's build that now, right? Start.spring.io. Okay, we go here. We want the web. We want the OAuth client. We want client here. Hit go. Terminal UAO client.zip. And this is just going to be a simple application running on server port 8081. Okay, and we'll make that a little bit bigger. OAuth client registration, spring.client secret equals spring. We're just telling this client, this application, what client from the auth server it should attempt to do its work, right? And the scope is OpenID and profile. OpenID is a standard that's on top of OAuth that guarantees that you have an endpoint you can connect to get information about the user, the email, the username, whatever. That way you have a standard way to fill out or do a sign-in with kind of functionality. Anything else I need?
We need an issuer URI.
Thank you. Okay, the issuer.
From the provider.
Not that one. It's the Spring Security registration provider .spring.issuer URI HTTP, and this is going to be pointing to the auth server that we just stood up back in the original app. So there we go. That looks like it, right? Spring OpenID profile scope.
Can you autocomplete after Spring? I think we're missing one more thing.
After where?
Like duplicate that and then delete client secret and see what prompts.
Yeah.
No, I think.
Looks
good.
right.
Yep.
I think we're right. Okay, let's go ahead and restart that. And let's now go back to, we have to have a Java endpoint here. There's nothing actually happening. Localhost, am I not running? By the way, you can make sure this is working. Localhost 8080.wellknown OpenID config, that's working. So now, and the password and the ID is Spring there. So now, the localhost, /. That is very important.
Yeah.
Do not make that mistake. Okay, so 127, because we're on a different, it distinguishes based on cookies, right? So 127, did I actually write the Java code? I did not.
No.
There we go. We're going to create another controller here on the client, the OAuth client, response body, get mapping / map of string, hello, inject the principal, turn map.of message, hello from the client, principal.getName, right? So let's restart that. 8081, go. It's redirected me back to 8080, the auth server, because it doesn't know who I am. It's rejected it, right? I'm going to log in with a one-time token here. Rob, got console mail. Go back to this. Copy that URL. Paste. Okay, and then it says, hello from the client, Rob. Right? So that's pretty nice. I've got a client which is able to act on behalf of Rob by logging in a well-known place, the auth server, which is kind of like sign in with Facebook, sign in with Google, sign in with whatever. But still, I might have other services that in turn will get messages from this client, right? This is the front end. This is the user page that the user visits. But they may in turn rely on other services. How are those things going to know who I am? I want to have an API somewhere. So let's go back and go to start.spring.io, and we're going to create a OAuth resource server, API, resource server, web, enter, API.zip. And here, this API is going to be kind of like the client, except that it's not going to incept the token. It's not going to do any redirects. It'll have a simple filter. Either you have a valid token that can be validated by talking to the authorization server, or you don't. Simple, right? So API. And here we'll just copy and paste the controller that we just built. Okay, go to my Maven build. Don't fail me now, IntelliJ. Come on. All right, good. And we want this controller at response body, application.properties. this will be an issuer. So this is much easier. You just point it to the issuer. HTTP no/8080. Yeah.
Yep.
Okay. Port is 8081.
8082.
2. Thank you. And that's it. So we're going to restart this. I'm going to go back to the client now and rework it now to make a request. Instead of just returning the result directly, we'll make a request of the API, okay? So imagine we're going from the front-end website to the downstream API, rc.get.uri http localhost 8082 retrieve body new parameterized type reference of map of string, right? Okay, and then we have to specify a header containing the current accessed, the current valid token, right? So h.setBearerAuth, we can get the token by injecting it. So registered, okay, there's that, and we want the valid access token, authorized client.
So the registered OAuth 2 authorized client is an integration with Spring MVC and Spring Security OAuth that gives you access to the access token, and it'll automatically refresh it and stuff like that for you.
Okay, so URI goes first. I always forget this. Okay, good. Retrieve, get the body, and then response, and we would just return the whole thing like that.
Yep.
Looks okay to you?
Looks great.
Great. Okay, restart. Okay, so now, where do we go? 127, 8081.
Yes, sir.
/. Oh, let me. 127. Okay. One-time token for Rob. Send the token. Go back to the auth server. Copy that URL. Paste it. And where'd I go? 8081. Whoop. 127.
Yeah, you can't go to 8081.
Oh yeah.
Yeah, on 127. Yep.
Whoop.
It's
What?
127 now.
I did. Okay.
Yeah, okay.
Ask him for this. There you go. Console mail again. Copy that URL.
What's happening is cookies are getting clobbered because cookies are only unique per domain, not domain and port. That's why we're using 127.
Let me change this to be from the API. Okay, refresh. And there you go. So now I have an auth server. The auth server can let me do login with usernames and passwords. Those passwords are secure. They're easily migrated. We're using the latest and greatest passwords. But even better, we support passkeys, so you don't need those passwords in the first place. And we support one-time tokens. All those allow you to get logged into the auth server. But then the auth server can vend tokens to clients, which can then use them and require somebody to log in. And if they don't have a valid token, it redirects them to the auth server to get that token. Once they have the token, you can send that to other APIs in the system, and then they can use that and validate it with the authorization server as well. So our identity is tied to this token, but that token can come from a fingerprint, from your Face ID, from YubiKey, from your Google, Android. I don't know what it's called. I'm sure there's a thing where you can do a factor of some sort besides typing in a password.
It's the Whizzy Bang.
Yeah, that thing. Yeah, this is an amazing result. This is here, friends. 3 microservices. Where's my Java code? Here we go. 3 microservices, a couple hundred lines of Java code across all these things combined, and we now have a secure microservices architecture, single sign-on.
Multiple ways of authenticating.
Yeah. I want to thank you for coming. I hope you had fun. Did you have fun? Did you learn something new? Okay, great, because I did too, which is that this talk needs a little bit more time. So it's slightly longer. Hey, can we get a selfie? Okay, everybody just pretend like you're happy, okay? One more time. Here we go. Just turn around, say, security! Guys, come on. Hey, ready? 1, 2, 3, go. Security! Yeah, thank you. Have a good one, everybody.
Hey, we finished on time.
Well, it says 30 seconds left.
30 seconds.
No,
We needed...
no, it's going up.
Oh,
I think we're over 30 seconds.